Now we know how to combine the elements, then anions, right, with metals or non-metals. Okay, now we are going to naming those substances that we have combined in the previous session. So we need to be able to name them. Basically, that's what we are coming to do. But here, because of based on everything that we have learned so far, everything we've gathered, yeah, you have to actually start getting familiar with some of the things already, and some of them you have to know them by default. At least every chemist, right, knows some of these elements, some of the substances, some of the knowledge. You have to know them. You have to know them because that's what we're going basically going to help us in this session. So, first thing that I would stress on is that these substances that are these anions that we named previously are just a common anions that happens, like binary anions that appear in most of our substances, in most of the salts that will be forming. So this one, SO42 minus, SO32 minus, NO3, all these ones, I added this one, bicarbonate ion. This is HCO3 minus. It's similar to CO32 minus, but here there's one hydrogen already coming before HCO3 minus, right? So you have to know these binary anions. So something like SO42 minus, we all know that it's tetraoxosulfate 6 ion. Tetraoxosulfate 6 ion. So you have to know them. So SO32 minus, you have to know their names, right? You have to know this at least these basic ones. And also you have to know the charge that they carry. For example, SO4, right? As an ion always carry a 2 minus. You have to know that. Just like how we know for oxygen. You know that when we are doing oxygen, we have O2 minus. We know that oxygen is 2 minus. Chlorine is 7, so Cl minus and all that. How we know them and we use it to calculate most of the oxidation number for the metals. Then what we are going to do for this SO4, you have to know that it's coming with 2 minus. SO3 also are coming with NO2 minus. These ones you have to know their charges, basic charges. You have to know them and as well know the name of the entire substance. So now how do we name them now? Now I'm assuming that we have watched the previous video and you know the names of these anions. So something like naming sodium Na2SO4. So Na2SO4, we have done some names already. Remember when we were doing Na2O, when we're naming this anion, right? This one is which metal type? This is metal type 1, so we don't have to calculate the oxidation state. We don't have to calculate the oxidation number. So this one was just sodium oxide. So we don't have to go and you don't have to go and then be calculating oxidation because sodium is a metal type 1, and if it's a metal type 1, we just don't bother ourselves calculating anything. So it's straightforward sodium oxide. But then here is an anion, and for the anion, we say we are not going to be having oxide IDE at the end. We are having ozo and it somewhere. We did that in the previous session. So we know that this SO4, right, is tetraoxosulfate 6 ion, right? But here it's not in terms of ion, so we are going to remove the name ion from the front, right? So normally, if we were just having SO42 minus alone, let me illustrate that properly. When we're having SO42 minus, we call it tetraoxosulfate 6 ion. This is what we called it. But then now it is now in a compound. The compound is Na2SO4. So we know that this one has combined. So sodium is here, Na plus, and so these two came to combine here, and then this one came to combine here because it's one. There's no bracket. That's why you have the Na2SO4. But then it is this one. This tetraoxosulfate 6 ion is now in a compound. We go to the metal, right? Because it's metal type 1, there's no need to calculate the oxidation state of the number of the metal. So we just say sodium. Just like how we say sodium oxide for the oxygen, it's just sodium tetraoxosulfate 6. Instead of adding ion, it is no more an ion, so we just remove the ion. And then we just say the name is sodium tetraoxosulfate 6. Sodium tetraoxosulfate 6. This is the name. So remove the ion because no more SO4 is no more acting like an ion. It's now in a neutral compound. So it's combined with sodium, and sodium is not having any oxidation number just after it because it's metal type 1. Let's imagine that we were having copper. If we were having copper here, copper would have been something like this, CuSO4. So CuSO4, copper is what? metal type 2. So you need to calculate the oxidation number of the copper. How do you do that? You say copper is appearing once here, right? It's 1 times X plus SO4 is appearing how many times? Once. Because if it is more than one, it will have been in a bracket and something here. But it's not in a bracket. So it is SO4 is appearing once. The entire SO4 is appearing once. That's what we have. Multiplying, what's the charge on the SO4 is 2 minus. So we'll have 2 minus here. So we have minus 2 here is equal to 0 because now it's in a neutral compound. It's not like iron where we equate something to this, but then if you calculate here, X will be equal to plus 2. So the name will have been copper 2 tetraoxosulfate 6. Copper 2 tetraoxosulfate 6. So that's why I said that you have to know the name of the anion. These common ones, at least you have to know them. That's what we did in the previous session. Know how to name them. And when you know them, you get familiar with the names. And then what you have to worry about now is how to add the name of the metal. How to add the name of the metal. So for the sodium was metal type 1. We get a sodium tetraoxosulfate 6. But here copper is metal type 2. So we needed to calculate the oxidation state. So you have to know the names of the anion and also the charges that they come with. Let's use another compound like PO4. Should I use PO4? Let me use something simple like this guy. I'm going to use this guy with copper, or let me use it with zinc, right? ZnNO3. That's because Zn is having a default charge of the Zn2+. You have to know that. We talked about that already. So, but it's a metal type 1. So if it's a metal type 1, we need to know the name of this guy. What's the name of this guy? Is triazonitrate. We named it in the previous section. What's the charge? What's also be the charge? The charge is -1, right? Let me see, 5 ion. This is a triazonitrate 5 ion on its own. That's the name on its own. But then we are coming to add a metal. So if you are going to add a metal, the metal is zinc. So we are going to zinc. We are not going to calculate the oxidation because zinc is a metal type 1. This is a metal type 1. We don't have to bother calculating anything. So what we have to do is just go here and delete this name. This ion, remove the ion, and then this is the name, zinc triazonitrate 5. Zinc triazonitrate 5. That's the IUPAC name of this particular compound. Let's now assume that I'm now using Cu. Let me remove this one. Yeah, CuNO, this thing, whatever. So copper is appearing once, right? I have to calculate the oxidation state because copper is a metal type 2. So X plus 1 NO3, the entire NO3 is appearing once. So I've been stressing over that many times. I have to remove the anion so that it can even help you get the frequency. So here NO3 is appearing once, right? What's the charge on NO3? Is -1, so it's -1. You write -1 is equal to 0. Equal to 0 because it is now in a neutral compound. It's now in a neutral compound. It's not like an anion where we have to equate it to the ion, right? So we are done. So X is equal to +1. So X is equal to copper is +1. So then the name will now be copper 1 triazonitrate 5. Copper 1 triazonitrate 5. Now that is the name of the substance. Yes. So so you can try PO4 3- and use any metal type 1, metal type 2, right? Know the name of the PO4 3-. If you don't know how we did this, go to the previous session, watch how we took our time to explain how to name the anion. Now you come back here. Now you use that anion that you name now to combine it with a metal, whether metal type 1 or metal type 2. If you don't understand metal type 1 and metal type 2, watch our video on metal type 1 and metal type 2 to also solidify that concept. There are examples that we solve along the way before getting to the anions and naming. Yes, so do this exercise. If you make any challenges, make sure you say it in the comment section or you join our online class. See you in the next session.